welcome Bridge, good to see you. Today we're going to continue talking about equations, but now specifically what it means if we're dealing with inequalities, which are working very similar to equations. Some of this may be review, but again, very good idea to get some examples down in your notes. This is formal notes, so I will be checking them off when you come back to Blackman 107. Okay, so here's some notes about inequalities. Inequalities are pretty much very similar to equations, but instead of using an equal sign, right, they're going to use these signs. And again, anything that I've underlined in blue today would be a great idea to get down in your notes. So inequalities use these signs: less than, wow, less than or equal to, right? If I have that little line underneath my less than sign, then that means your solution could also be equal to whatever that number is. On the other hand, we have greater than, and we have greater than or equal to. So if we have x greater than or equal to 3, x could be equal to 3. X could be equal to 4, since 4 is greater than 3, right? Okay. Pause if you need to on those. X less than 5 here, so just a little example, means that whatever value of x is, it must be, I'm just going to fill in, less than, all right? So again, solutions to equations are just one single number. But if we're looking for solutions to inequalities, it could be several solutions because, hey, if we're looking at x less than 5, x could be equal to 4. X could be equal to negative 10. X could be equal to 4.991, right? There's a ton of different solutions. As long as x is a number that is less than 5, it would be considered a solution to this inequality, all right? So kind of the difference between equations and inequalities is equation, you solve for x, and x has to be equal to that one single number. Inequalities, you solve for x, but we've got this kind of condition, so x could be really anything as long as it's less than 5, or as long as it's greater than or equal to 3, all right? So pause if you need to on that. Maybe you want to get an example down there about x being less than 5. Let's talk about graphing some inequalities here. So when we graph our inequalities, basically we're looking at an entire solution set. All right, so I've got a little table, might be a good thing to get down. If you have an inequality that's in this form where x is on the left-hand side here, and maybe you have less than or equal to, or you have greater than a, just a constant. So over here, I'm going to say a is a constant number. So whenever you're finished solving for what x is, as long as x is on the left-hand side, again, x is the variable that you're solving for. As long as x is on the left-hand side, then you can use everything in this table to help graph a solution set. All right. And I'm going to do this, so you may want to pause and get that table down. I'm going to do this with an example. So x greater than or equal to negative 3. So when we graph a solution set, we're really just looking at a number line. All right. And these ones are pretty easy to make, so, take a second, put one down in your notebook. We're just looking at a number line. I'll start with 0 because that makes it easy. If we're looking for all of the x values that are greater than or equal to negative 3, I'm going to go find negative 3 on my number line. And since it is a greater than or equal to, so I'm going to go check it out here. Hey, greater than or equal sign says that I need a closed circle, and my arrow is going to be pointing to the right. So I'm going to put that circle above negative 3. I'm going to fill it in to show that is a closed circle. And then I'm going to draw my arrow pointing to the right. It is pointing to all of the x values that are greater than or equal to negative 3. The reason why I used a closed circle is to show that we could include negative 3 in our solution set. So that arrow is describing, hey, negative 1 is a part of that graph. 1/2 is a part of that graph. Negative 2 is a part of that graph. Since we have a filled dot on negative 3, Negative 3 is part of that graph, so all of those values are possible solutions to your inequality. All right. Okay, let's look at a couple more here. We're going to graph 6x minus 8 greater than x plus 7. So now it's not just a simple thing as x greater than or equal to negative 3. We're going to have to actually solve to find that condition on what x is. So I'm just going to add my number line in here pretty quick. Negative 2, negative 3. So I'm going to solve this one real quick. Let's say I've got x on both sides of the equation, so I'm going to minus x from both sides. It's going to give me 5x minus 8 greater than 7. I'll add 8 to both sides. Now I have 5x greater than 15. Lastly, divide by 5 on both sides, and x is greater than 3, positive 3, all right? So you can go revisit that table there. The greater than sign says we're going to have just an open dot, so I'm not including a positive 3 in my solution set. Again, it doesn't say greater than or equal to 3. It's not going to work. So if I put an open dot, that's really big. Go back to red. Put an open dot above positive 3. And since we're looking for all of the x values that are greater than 3, the arrow is going to be pointing to the right, because if I point that arrow to the right, all of the values like 4 and 5 and 6, those are all values that are greater than 3. All right. Also, last thing for this video, if you multiply or divide by a negative number in your inequality when you're trying to solve for this thing, you must flip the inequality. And we'll talk more about exactly why that happens, but just make a little note that if you multiply by a negative number or a negative 1 or a negative 5, you have to flip that inequality. So we are going to, again, graph this. So I'm going to add my little number line. Negative 2, I'll add another negative 3 there. I have x minus 8 is less than or equal to 10. So to get x by itself, I'm going to take care of that positive 8. It's positive, so I'm going to minus 8 from both sides. And now I have negative x is less than or equal to 8 minus 10 is just a positive 2. I'm left with negative x, and I want just x, right? So to get rid of that negative, you could multiply or divide by negative 1. Doesn't really matter, just as long as we change that sign so we have a positive x. I like to just multiply by negative 1. Again, this is the same thing that we do when we solve our equations. But as soon as I multiply by that negative 1, I've multiplied by a negative number on both sides. So while that is going to change it to a positive x, that inequality is going to flip. It's still going to stay equal to, but instead of less than, it's going to become a greater than or equal to. And then the 2 times the negative 1 is just a negative 2. So that inequality is the same thing as this guy here, and that is something that we can graph. So if we were looking for solutions to this inequality, it would be all of the x values that are greater than or equal to, see how I'm filling in that dot, greater than or equal to negative 2. So if I plugged in 0, since 0 lies on this line, it lies on this little solution set. If I plugged in 1, or if I plugged in 1/2 into that equation, or into that inequality, it would make it true. So just for example, let's just plug in 0. Why not? So if I plug in 0 into 8 minus x less than or equal to 10, I'm going to get 8 minus 0 is less than or equal to 10. Well, 8 minus 0 is just 8. So is 8 less than or equal to 10? Yes, it is. That is a true statement. So I know that I have graphed my inequality correctly. All right, short video, a little introduction to inequalities. Please come on back to Blackman 107 and we'll check off some notes and talk a little bit more in depth about these. See you soon.